Good day but rainy day mga kasi. Today, this is my topic that I will discuss. Main type of methodologies in the assessment of desirability in economic and environmental social aspect of constructing a highway proposal. Yan. Ito ay mga katwiran ng pagpipilian ng mga desisyon sa individual o pangkat na magiging balangkas sa paggawa ng desisyon na kung saan napapaloob ito ay ng appraisal na maaaring may ganap. Una ay problem recognition na may dapat ang isang problema at ang isang desisyon ay nasasalamin. Hindi yung ang desisyon mo ay wala na sa problema na gagawin. Goal identification. Yun. Ang detalye sa paggawa ng desisyon ay nais na resulta na kilalabas ng dapat ng proseso. Number 3, identification of alternative highway scheme. Iba't ibang potential na solusyon dapat ang naipon, hindi isa lamang kasi wala nang pagpipilian. Information search. Information search ay ang gumagawa ng desisyon dapat ay ang naghahanap upang makilala ang mga katangiang nauugnay sa mga maaaring solusyon, sa mga alternatibong solusyon. Number 5, assessment of information on alternative highway scheme. Ang information ay kinakailangan para sa paggawa ng isa tungkol sa ganitong pagpipilian ay natipon at nagkasundo at sinasaalang-alang. Number 6, selection of prepared highway scheme. Ang isang ginustong pagpipilian ay pinili ng tagagawa ng desisyon sa pagpapatupad para sa hinaharap. Evaluation is dapat hindi siya 30 minutes lamang kasi kailangan siya talaga ng paniguradong desisyon o pagpaplano. This is economic appraisal highway scheme. Dapat yung development ay require siya sa economic assessment or route option under consideration. This is yung consider time value of money is important concept engineering economics that estimate the change in worth of an amount of money over a given period of time. Ay yung net present value, internal rate of return, benefit cost ratio. Mamaya i-discuss kasi mas doon pa siya use or mas doon pa siya magamit sa sunod. The cost benefit analysis. Using this method, any proposal having positive net present value is economically sustainable in absolute terms, where competing project options are being compared, assuming they are being used in identical capacities over the same period. The one will numerically larger net present value is select. My main step in the technique una ay identifying the main project. Syempre kailangan mo munang ma-identify yung main project para makagawa ka, hindi yung hula ka lang ng project, ganun. Kasi there are many procedures about identifying and defining project option. Una ay yung drawing on the personal experience of decision maker. Dapat ang magagawa ng plano ay yung dapat may experience na, hindi yung hindi yung nagagawa-gawaan lang. Pangalawa ay making comparison between the current decision problem and one previously solved in successful manner. Dapat kung gagawa ka ng mas magiging maganda yung gawa mo kung ano mo muna yung current decision ngayon or yung dapat na nakaugnay doon sa agawin mo, tsaka yung or magiging basihan mo yung mga naging successful pa na natapos na. And thus examining the relevant literature. Yan. Ito yung two main phases. A group of people but put forward in the environment as in many ideas as possible relevant to the problem being considered. At the second phase required the planning engineer to return to normal judgmental mode to select the best option from the total list, analyzing each for technological, environmental, and economic practicality. Number 2 is identifying all relevant costs and benefits. Siyempre, kung magagawa ka ng project, hindi yung basta ka nalang magawa. Tingnan mo muna yung costs at benefits niya. Hindi yung mura nga, kaso yung benefits mo naman ay may malaking epekto sa kapwa mo. O di kaya ay maganda nga yung epekto, sobrang mahal or ganun. Malaking halaga yung magagastos. Pangit din pag ganun. This is the main group. Ito yung mga positive at negative changes na mangyayari sa pag nagawa ka pag nag-identify ka or hindi ng project na gawin. Ito yung 3 primary user benefits. Reduction of vehicle operating costs, saving in time, reduction in the frequency of accidents. Reduction vehicle operating costs constitute the most direct potential benefits derived from a new upgraded highway project. Saving in time, reduction frequency of accident. Dapat kung gagawin mo ay hindi man yung laging may na-aksidente. Mga nakaano siya sa second steps. Pangatlo is economic right residual value and discount rates. Dapat yung agawin mo pang long life, hindi yung wala pang 2 or 3 taon sira na. Number 4, use of economic indicators. Assess basic economic viability. And kung nakuha mo yung dalawa na discount rate are set in place, tsaka yung disallow or cost benefits, magiging maganda yung pagdi-decision mo ay magiging matibay or maganda. Yan, NF3 techniques. Yan, net prevent na dito na. Ito yung formula ng net present value, NPV. R sub T over 1 plus I. Yan. Tapos ito naman ay when yung net cash flow niya ay even or yung cash flow niya are equal. Ito ang formula. Tapos ito naman pag uneven or yung net cash flow niya ay vary from period to period. Ito naman yung formula ng benefit cost ratio. PB of benefit expected from the project and over PB of the cost of the project. How to calculate? Hindi ko na masyado kasi limited lang yung time na binigay sa amin. So ito, yung step sa pag-calculate ng benefit cost ratio. Example. So hindi ko na masyado explain. Ito yung example niya. Ito yung sa internal rate of return. Yung formula. Example. Yan. NBP will estimate economic worth project in terms of percent worth total net benefits. The R, the internal rate, yon I will give for each option under consideration. Ang benefit or cost ratio ay based on the ratio of present value at benefits naman. Yung 3 methods na ito nakadepende discounting to arrive a final answer. All is used correctly should answer entirely consistent with each other. Advantage and disadvantage cost benefits analysis. Siyempre, pag magawa ko may advantage at disadvantage din. Sa advantage ay yung the use of common unit measurement money, facilitate comparison between the alternative highway proposal and hence a decision making process. Tapos, given the focus, method, and benefits and costs of a highway in question to the community as whole. It offers a broader perspective than a narrow financial investment appraisal, concentrating only on the effects of the projects on that project developers with the government or a group or investment funding tool scheme. Ito yung disadvantage naman. Method. Suitable for comparing highway proposal design. Yan. Isang mga disadvantage. Yan. Payback analysis. It is an extremely simple procedure that is particularly useful in evaluating proposals such as privately funded highway project where tolls will be imposed in users of the facility in order to recover construction costs. Ito yung formula niya, payback period. N sub P equals to C sub O divide net annual savings. Yan. Meron din siyang iba't ibang equation na dapat sundin. Equation 3.2. At ang equation 3.3 niya ay kapareha sa equation 3.1. Yan. So, yun lamang. And thank you. Have a good day to all.
Pleasant day to everyone, especially to Engineer Wheeler Dayahan Sr. The topic that I am going to discuss is about the environmental appraisal of highways scheme. So the cost-benefit framework for a highway project addresses the twin objective of transport efficiency and safety. It makes no attempt to value its effects on the environmental. Environmental evaluation therefore requires an alternative analytical structure. The structure developed within the last 30 years is termed Environmental Impact Assessment or EIA. So dito sa environmental appraisal of highway schemes, meron dito yung process na ginawa ng statutory under the National Environment Policy Act 1969, which nag-require ng preparation para sa environmental impact statement for any environmentally significant project undertaken by federal government. Nag-prescribe din dito ng format requiring the developer to assist para maka-ensure yung directive nag-adequate siya ng consideration is given to the environmental effect of a development project by providing a mechanism for ensuring that the environmental factor relevant to the project under the examination are properly considered within a formal statement. The directive also details the minimum information that must be contained within the environmental impact statement. These include, number 1 is a physical description of the project, number 2 is a description of measure investigate to reduce remedy the significant adverse environmental effect of the project, and last one is the data required of both identity and assess the main effects on the environmental of the project in question. Within the UK, since 1993, the Design Manual for Roads and Bridges has provided the format within the environmental assessment of highway scheme has taken place. Dito nag-identify ng 12 environmental impact to be assessed for any new improved road proposal. The 12 environmental impacts forming the assessment framework are: number 1 is the air quality, pangalawa is cultural heritage, pangatlo construction disturbance, pang-apat ecology and nature conservation, panglima is the landscape effect, pang-anim land use, traffic noise and vibration, pedestrian, cyclist and community effects, vehicle travelers, water quality and drainage, geology and soil, and the last one is the policies and plan. Some of the above impact can be estimated in quantitative terms, others only qualitatively. The exact method of assessment for each is detailed within the design manual for roads and bridges. So, yung design manual for roads and bridges, siya yung imperative that the environmental information is presented in as readily understandable as a format as possible so that the both member of the public and decision makers at the highest political level can maximize their use of the information. So, dun sa design manual for roads and bridges, meron siyang tatlong relevant appraisal group. Number 1 is the local people and their communities. Traveler, which is the drivers and pedestrian, cultural and national environmental. So, dun sa the new approach of appraisal, nag-summary sila ng assessment of the scheme in question against the following 5 objectives and their constitute impact seen by the government as being central to transport policy. Number 1 is the environmental, which is ang impact is noise, air impact, landscape, biodiversity, heritage, and water, and safety. Pangalawa is the economy, journey times, cost, journey time, reliability, and regeneration. Pangatlo is yung accessibility, pedestrian, access to public transport, community severance, and the last one is the integration. So, ang subtopic na under ng environmental appraisal of a highway scheme is the basic element of highway traffic analysis. The functional effectiveness of a highway is measured in terms of its ability to assist and accommodate the flow of vehicle with both safety and efficiency. In order to measure its level of effectiveness, certain parameters associated with the highway must be measured and analyzed. Yung meron na apat na property na dapat i-analyze. Number 1 is the quantity to traffic. 2, the type of vehicle within the traffic stream. 3, the distribution of flow over a period of time, usually 24 hours siya. And the last one is the average speed of the traffic stream, the density of the traffic flow. So, the next one is, para makuha natin yung traffic density, ang gagamitin nating formula is K is equal to N over L. Ito yung formula ang gagamitin natin. Tapos, ito din. May summation na siya ng para makuha yung space mean, speed u. So, the next one is speed density relationship. Flow density relationship. So, ito yung parabolic illustration dun sa flow density relationship and speed flow relationship. Gagamitin pa rin natin siya. This relationship is again parabolic in nature. Lamang po at maraming salamat. Thank you.
Everyone, my topic is about determining the capacity of highway, the level of service approach, and some of its definitions. Maximum service flow rates for multi-lane highways, maximum service flow rates for two-lane highways, sizing a road using the highway capacity, manual approach, and estimation of AADP. Determining the capacity of a highway. There are two approaches to determining the capacity of a highway. First, which can be termed as a level of service approach. It involves establishing from the perspective of the road users the quality of service delivered by a highway at a given rate of vehicle flow per lane of traffic. Second is putting forward practical capacities of roads of various sizes and width carrying different types of traffic. Within this method, economic assessment are used to indicate the lower border of a flow range, the level at which given load width is likely to be preferable to a narrower one. Level of service approach. The level of service describes in a qualitative way the operational conditions or traffic from the viewpoint of road users. It gauges the level of congestion on the highway in terms of variables such as travel time and traffic speed. The highway capacity manual in the US lists 6 levels of service training from A, which is the best, and to F, the worst.
Some definitions. In order to determine a road's level of service, a comprehension of the relationship between hourly volume, peak hour factor, and service flow is vital. V or hourly volume is the highest hourly volume within a 24-hour period. PHF or peak hour factor, the ratio of the hourly volume to the peak 15-minute flow, or V sub 15 enlarged on hourly value. Therefore, PHF is equal to V divided by V sub 15 times 4. SF or service flow is the peak 15-minute flow, V sub 15 enlarged on hourly value, whereas SF is equal to V sub 15 times 4. Maximum service flow rates for multi-lane highways. The highway capacity manual generates maximum flow values obtainable on a multi-lane highway given a certain speed limit and prevailing level of service. Given the existence of ideal conditions, the maximum service flow, or SF max sub I, can be defined as SF max I is equal to C sub j times V over C times N. N is the number of lanes in each direction, and C sub j is the capacity of a standard highway lane for a given speed of j. The maximum ratios of the flow capacity for each level of service and design speed limit are given in Table 4.2. Maximum service flow rates for two-lane highways. Where one lane is available for traffic in each direction, a classification of two-lane highway applies. The capacity of such highway is expressed as two-directional value rather than the one-directional value used in the previous section for multi-lane highway. The formula for service flow is obtained SF sub I over 2,800 times V over C sub I. When designing a new roadway, a desired level of service is chosen by the designer. This value is then used in conjunction with the design traffic volume in order to select an appropriate cross-section for the highway. AADT or annual average daily traffic for the highway is multiplied by a term called the K factor such that DHB or design hourly volume is equals to K sub I times the average annual daily traffic, where the value of K corresponds to the highest annual hourly volume. If the K sub 1 value is used, the road will never operate at greater than capacity but will have substantial period when it operates at well under the capacity, thus representing to some extent a waste for the resources spent constructing it. Finally, since DHB is a two-directional flow, the flow in the peak direction is estimated by multiplying it by a directional factor D. DDHB is equal to K times D times AADT. Estimation of AADT for a rural road in its year of opening. Selection of the appropriate layout for a rural road requires that the high and low forecast for the opening year is estimated.